Hello guys and welcome to this video where we are going to discuss the question Hamiltonian path and cycle. So let us understand the question first. So we have been given a graph something like this, and we have given a source vertex from where we're starting. Okay, what we have to do is we have to paint all Hamiltonian path and cycles with every path should end with a dot at the end, and every cycle should end with a star at the end. Okay, now what the first question should be, what is a Hamiltonian path? Or for a cycle in that case, what is a Hamiltonian path or what is a Hamiltonian cycle? Okay, so Hamiltonian path is any path through which we can traverse all vertices of a graph where we have visited all the vertices exactly once. Okay, so what I mean by that is, if we have a path where every vertex is visited only once, but we have visited all the vertices exactly once. Okay, so one and only one time. Okay, if there is a possible path, then that path is called as Hamiltonian path. For example, let us say if we start from 0, we can go to 1 or 6. Let us go to 6. Okay, we went to 6. Now we can go to 5. I went to 5. Now we have options to move to 1 or 4. Let us say I went to 2 1. Okay, now we have options to move to 2 or 0. I moved to 2 because I have already started from 0. Okay, now let us move to 3. Now after 3 I went to 4. Now what we can see from here is that I have visited all the vertices where every vertex has been visited only once. Okay, so if I can form a path where every vertex of the graph can be visited, but they can visit only once. Okay, so that path is known as, this is nothing but a Hamiltonian path. Okay, so this is a Hamiltonian path. Okay, now what we have to know is that what is a Hamiltonian cycle. Okay, so if we can form a certain Hamiltonian path whose last vertex that we have visited is the neighbor of the starting source vertex. What I mean by that is, let us say if I started from 0 and then I went to 1, then I went to 2, then I went to 3, then from 3 I went to 4, 4, from 4 I went to 5, and then I reached 6. So I have visited all the vertices, and every vertex has been visited only once. But what we can observe from here is that 0 and 6 are neighbors. That is, 0 and 6 have a direct edge between them. So this is a Hamiltonian cycle. Okay, so this is the main difference between a path and a cycle, is that the last vertex that we have visited during forming the path is the neighbor of the starting vertex. That is, the last and the first vertex have a direct edge between them. Okay, so if the last and the first vertex have a direct edge between them, then it is a Hamiltonian cycle. Otherwise it is a Hamiltonian path. Okay, so let us form a tree for this. So how we tree showing how we are going to visit all the other vertices. Okay, so this question is very similar to the question that we have done earlier, which is the print all paths problem. Okay, so a lot of logic is going to be similar to that, just we have to check for a cycle or a path. Okay, so let us start. So let us start from 0 only. Okay, so let me remove this part. Okay, so let me start from 0. So if I start from 0, then what are the neighbors of 0? Okay, so I have options to visit 1 or visit 6. So let me visit 1. If I visited 1, then I have options to visit 0 and 2, because 0 and 2 are neighbors of 1. So I can't go to 0 because I have already visited 0. So I can only go to 2. Now if I went to, What are the neighbors of 2? I have 1 and 3. I can't go to 1 because 1 has been already visited here. So I can only go to 3. When I go to 3, I have options to go to 2 or 4. I can't go to 2 because 2 has already been wasted. So I went to 4. After 4, I have options to go to 3 or 5. I can't go to 3 because it has already been wasted. So I went to 5. Now, 5 have options to go to 1 or 4 or 6. So we can go to 1, we can go to 4, we can go to 6. But 1 and 4 are already visited. As we can see here, 1 was visited here, 4 was visited here. So I can't go to any of them. So I'm going to go to 6. Now what we can see is that we have visited all the vertices. So the path formed is 0, 1, 2, 3, 4, 5, 6. So in this order. Now what we can observe that we have actually formed a Hamiltonian cycle. Why? Because 6 and 0 have a direct edge between them. So this is a Hamiltonian cycle. Okay. And after printing this path, I'm going to add a star in them. Okay. Star after this. So this is the Hamiltonian cycle. Now let us visit other paths. Okay. So what I can do is I'm going to retract. Now I've already exhausted 1 and 4, so I can't visit any other vertex, so I'm going to reach 4. Same with 4, I can't go to any other vertex because I have already visited 3. Now if I go to 3, so what is happening here is that I forgot to mention, when we retract back, we actually make the current edge unvisited. Okay, so as to, if we start forming any other path, we can visit this vertex again. So if we don't make this unvisited, we won't be able to include this in any other path, so we can form all possible paths. Okay, so remember this point. After retracting, after returning back, before returning back, I have to make them unvisited. So after the recursive call, I will make them unvisited. Okay, so I return from here. This is the base case because we have visited all the vertices. I'm going to explain that more. So I return back, I make this unvisited, I make this unvisited, 5 unvisited, then I make 4 unvisited, then I reach 3. 3 has options to go to 2 and 4. We can't go to any other place, so we track back. Then 2 has options to go to 1 and 3. We can't go to anywhere else, so we retract back. We reach to 1. We can't go anywhere else, so we reach to 0. Okay. Now what is happening? I'm going to visit 6. So let me remove this part. Now if I visit 6, so if I visit 6, I have already explored 1, so let me remove this one. So if I go to 6, what are the options from 6? Okay, so as we can see here, from 6 we have options to go to 5 or 0. So we have options to go to 0 or 5. We can't go to 0 because we have already visited, so we go to 5. From 5 we have options to go to 6, 1, 4 and 6. We can't go to 1 because we can't go to 6 because we have already visited it, but we'll go to 1. Okay, so if we go to 1, we have options to go to 0 or 2. We can't go to 0 because it has already been visited, so we go to 2. From 2 we have options to go to 1 and 3. Again we can't go to 1 because we have already visited that, so we will go to 3. Okay, so we are following this path. Okay, and here when we reach 3, we have options to go to 4 or 2. We can't go to 2, we can go to 4. Okay, so from 4 we have options to go to 5 or 3. So 3 or 5. Since we reached here from 3 only, we can go to 3 again. So I'm going to go to 5. And here we have reached our base condition. So what we understand from here is that we understand two things. First thing is that since our last vertex is 5, so let us write the path first. The path is 0, 6, 5. So let me write this in different color. The path is 0, 6, 5, 5, 1, 2, 3 and 4. Okay, so do 4 and 0 have a direct path between them? No, right? So this is not a cycle. This is actually a Hamiltonian path. Okay, so this is a Hamiltonian path and this one is a Hamiltonian cycle. So after this I'm going to print a dot. And the second thing that we understand is, the second thing is that we have got our base case, and that is when we have visited all of the possible vertices. Okay, so if we have visited all vertices, we will write our base condition where we will check if the path is cycle, if the Hamiltonian path is cycle or not. Okay, so let me write the code here and you will understand better how it is working. So here, first thing, I'm going to make a boolean visited array. Okay, let us make it. What would be the size of this visited? This would be nothing but the size number of vertices. So this will be VTCS. Now I'm going to call the function. So I'm going to name it Hamiltonian. So Hamiltonian. Now inside it, I'm going to pass the graph. Then I'm going to pass the source vertex. Then I'm going to pass the path so far. So starting would be empty string plus source. Okay. Then next thing, I'm going to pass this visited, and next thing is I'm going to pass a count. So why I passed a count here? So basically, how are we going to check if all the vertices have been visited? So one of the methods that we are going to use here is that I'm going to take a parameter count, and after every recursive call I'm going to update it. So I'm going to initially start with 1 because we are the source itself. Now after every recursive call I'm going to increase it by 1, and when this count becomes equal to number of vertices, I will return from here after doing my checking work if it is a cycle or not. Okay, so that is what I'm going to do in our code. So next thing is I'm going to write the function. So this would be public static void Hamiltonian, and let us pass the graph. Okay, so this should be okay. Now next thing is I'm going to pass this source vertex. Now I will pass the path so far, then the boolean visited array, and the count, the int count. Okay, now inside this function, what we're going to do is we are going to write the similar logic as we did in the print all paths function, print all paths question. So the first thing that we did there was make the current vertex that we are at as visited. So this is src true. Okay, this will prevent us from visiting the same vertex again and again in the same path. So that's what we did here. Now I'm going to visit the neighbors of the source. So right, for loop that we do in DFS. Now as usual I'm going to check if the neighbor is visited or not. If not, I'm going to make the recursive call. It should be graph. Now in place of src I'm going to pass ed.neighbor, and I'm going to add this neighbor to our path, and I'm going to pass the visited, and finally I'm going to increase the count by 1. Okay, and after we have done this, as I stated earlier, we have to make visited of the current vertex as false. After exploring all possible paths from that source, we have to make this as false so that we can form other paths from starting from a different vertex. So this is a very important point, is don't forget to do this, otherwise we won't be able to get all possible paths. So now only thing remaining is to add the base case itself. So as I stated here, when count reaches number of vertices, so we'll enter our base case. So how will we get this number of vertices? So as I declared the boolean visited array, I pass the size as VTCS. So that is how we are going to get our number of vertices. So if count is equal to visited dot length, so this will return us the number of vertices, okay, because the size is equal to number of vertices. So if this happens, what we are going to do is, in before returning, we are going to check if we have found a path or a cycle. So after this happens, we are going to declare a boolean is cycle variable. This will decide if the path is cyclic or not, and if it is cyclic, if it is true, I'm going to print the path so far and add a star at the end. Otherwise, I'm going to print the path so far and add a dot at the end. Now, how do we check if the path is cyclic or not? So, the thing that will decide if it is a path or not, if it is a cycle or not, is that how do we, how did we derive that this is a Hamiltonian cycle? So, what was happening here is the last that vertex that we are at is nothing but the neighbor of 0. So, if if any of the neighbor of the last vertex that we are at has a neighbor as the original source, then we can say that this is a path. What I mean by that is, what are the neighbors of 6? 6 is the last vertex here. So if we are entering the base case itself, that means we have traversed all possible vertices. So we are at the last vertex itself. So if the last vertex has a neighbor original source, so if any of the neighbors is original source, that means we have actually found a cycle. So here, what are the neighbors of 6? 0 and 5. So we have 0 and 5. Okay, now since 0 is the original source, we started from 0, that is, so this will actually make is cycle as true. So let me write it here, it would be more clear. I'm going to explore all the neighbors. How do I do that? I'm going to run a for loop ed, and I'm going to make, after this, in this I'm going to check if the last vertex has a neighbor as original source, okay, and which I'm going to pass in the function. If this is true, what I'm going to do is I'm going to make is cycle as true, because we have actually formed a cycle, okay, and I'm going to break here because we don't need to proceed, we don't need to iterate further. So I'm going to get original src from here. And what was the original src? Because src itself that has been taken as input, so I'm going to write src here, and I have also have to pass it here, okay. Now let us copy this and write, paste it here. Now let us try to run it. Okay, it should be she visited. Okay, okay, yes. This I forgot, so I can't pass count here. So what should be the initial count? Okay, since we are already including our source vertex in the path, so we should already start our count from 1. So we are already starting from some vertex, so we should start from 1. Okay, so this count should be 1 actually. So this should be 1. Okay, now let us see. So as we can see, we have printed all such paths. So there are 2 Hamiltonian path and two Hamiltonian cycles. So let us quickly see what is happening here. So what is happening is that let us let us assume that the path traversed was 0. Starting from 0, we went to, let us say, 6, then we went to 5, then we went to 1, then we went to 2, then 3, and finally we reached 4. Then what happened here is we check in the base case. Here the count becomes equal to number of vertices. So we reach our base case, and here we check if fourth neighbors, what are the neighbors of 4, 5 and 3, if any of these are original source. So original source was 0, so none of them are 0, so it will actually make is a cycle as false. That is why we will derive that this is actually a path, not a cycle. But for a path like 0 1, as we can see from here, 0 1, then 2, then 3, then 4, then 5, and then 6. If this path is followed, then what are the neighbors of 6? Those are 0 and 5. So 0 was the original source and 0 is the neighbor of the last vertex. So this means that we have actually found a cycle. Okay, so this is a path and this is a cycle. So this is how our code is working, and this is the whole code. So, and we have passed all the rest cases. So this is how we solve this question, and I hope you enjoyed the video. Please like and share if you did, and I'll see you guys in the next video. Thank you.